Today we are going to solve another compressible flow problem. This problem is telling us that nitrogen flows through a diverging section of a duct with area 1, which is our inlet, equal to 0.15 square meter, and the outlet section, which is A2, equal to 0.45 square meter, and Mach number 1 is 0.7, and pressure at the inlet is 450 kilopascal, and it is asking us to find Mach number at the outlet and also the pressure. So we know that we have a diverging section, and Mach number at the inlet is equal to 0.7, so our flow is a subsonic flow. So we know that in a subsonic flow, we know that in diverging section, when we have a subsonic flow, our Mach number is going to decrease in the direction of flow. So Mach number 2 is going to be smaller than Mach number 1. And we know the pressure of our inlet, which is 450 kilopascal, and the area is equal to 0.15 square meter, and area of the outlet is equal to 0.45 square meter. From previous video, we already know that in isentropic flows, stagnation pressure and temperature is going to remain constant. So P0 1 is going to be equal to P0 2, and we know that the relation between P and P0 is like this. So now we put Mach number 1 here, and we can find P01, which is equal to P02. This is going to be equal to P times 1 plus 1.4 minus 1 divided by 2 times 0.7 to power 2 to power 1.4 divided by 0.4, which is equal to 624 kilopascal. And we also know that A star, which is the area required for the flow to reach Mach 1, is constant throughout an isentropic process. So A1 over A star, which can be found from this table, for Mach number at the inlet, which is 0.7, is equal to 1.09. So from here, we see that A star is equal to 0.137 square meter. Now that we have A star, we can find the same ratio for our outlet, which is equal to A2 over A star. And if you divide 0.45 by 0.137, you see that it's going to be equal to 3.28. And if we go through this table, we see that we can find 3.28 both here and here. And since our flow is subsonic, as we said in the beginning, and Mach number in the outlet has to be smaller than 0.7, we can only choose this answer. And if we interpolate between these numbers, we see that Mach number 2 is going to be equal 0.17. Now that we have the Mach number of the second section, we can use the same equation which we use for finding the stagnation pressure to find the pressure at the second section. So we can write that P2 is equal to P0 times 1 plus 1.4 minus 1 divided by 2 times 0.17 to power 2 to power minus 1.4 divided by 0.4, which is going to be equal to, let me calculate it for you now. And the pressure at the outlet is going to be equal to 611 kilopascal.